Okay, so I'll start. Okay, what is cryptography, by the way? So cryptography or cryptology from the ancient Greek, meaning cryptos or hidden secret, to write or study for cryptology. It's the practice and study of techniques for secure communication in the presence of third parties called adversaries. So we use cryptography to write a hidden or secret message, or the study of writing a secret message or technique to secure communication between parties. Okay, so next we have Caesar cipher. Caesar cipher is one of the earliest known and simplest ciphers. It is a type of substitution cipher in which each letter in the plain text is shifted, meaning you shift depending on the count a certain number of places down the alphabet. For example, with a shift of 1, A would be replaced by B and, B would become C and so on. So if you shift 2, now you will shift 2 places. A would be replaced by 2 places. So A, B, C, we will start with Z and so on. The method is named after Julius Caesar, who apparently used it to communicate with his generals. To pass an encrypted message from one person to another, it is first necessary that both parties have the key for the cipher, so that the sender may encrypt it and receiver may decrypt it. So you should have both parties have the key for the cipher, so that the sender, me, I'm the person sending the encryption, so it would be encrypted, and therefore, when the receiver receive it, they can decrypt it. So for the Caesar cipher, the key is the number of characters to shift the cipher alphabet. The key is the number of characters to shift the cipher alphabet. So here's a quick example of the encryption and decryption steps involved with Caesar cipher. The text we will encrypt is defend the east wall of the castle with a shift key of 1. So in this example, defend the east wall of the castle. It is easy to see how each character in the plain text is shifted up the alphabet. Decryption is just as easy by using an offset of -1. So we have -1. Therefore, our plain text is A, B, C, D, E, F, G until Z. Then our cipher would become, because we shift negative -1, so our A will be B. Okay, our A will be B, our B will be C, our C will be D, and D will be E. So we have a shift of 1, and so on and so forth. So when we do a plain text, this is our plain text, and we want to encrypt the plain text, which is the ciphertext will be our encrypted plain text. So D is equivalent to E is equivalent to F, and F is equivalent to G to our cipher, and E equivalent to F, and N is equivalent to O here, and D is equivalent to E, and T, which is here, equivalent to U, which is U. H is equivalent to I, and E is equivalent to F. E, again, here in our plain text, it's equivalent to F in our cipher with a shift of 1. So A is equivalent to B, so on and so forth. So I hope you got that we have a shift of -1. Therefore, our ciphertext from the representation from the plain text of A, B, C, D until Z, we have a shift of 1, then it become B is becoming A and C becoming B, and so on and so forth, because of an offset of -1 or -1. We shift up the alphabet. So that's how we use Caesar cipher. We shift, or we used encryption, wherein we shift depending on the key and the number of characters to shift the cipher alphabet. So next topic is Symmetric encryption. So for symmetric encryption, it's an algorithm that takes a plain text message and converts it into a coded message or ciphertext that requires a key to both encrypt and decrypt the message. So the decryption method reverses the encryption. Okay, so the next slide, think of the key as a decoder ring. For example, it's the secret of the scrambled text that cannot be read without the key. So here, in the symmetric encryption, we have a key, meron tayong susi. That key holds the information on all the switches and substitution made to the original plain text. So we have a key. If we know what is the key, we can decode the switches and all substitution that was made on the original plain text. So in the symmetric encryption, the key is actually bundled with the algorithm. In this sense, the decoder ring is not universal. The changes in substitutions depend on the key and vice versa because the sender and recipient share the key. So it means that for you to decode, to encrypt and decode the alpha cipher text, you have to both parties should have, the sender and recipient should have the key. So let's go with the next slide, the ciphertext. What is a ciphertext? It's the text that show that is now scrambled and ready to be sent. So this is the encrypted text. It may look like a random stream of data and is unreadable. So decryption algorithm. In a decryption algorithm, this is the secret key, the decoder ring, is applied to the ciphertext. Ito na yung susi in which we wanted to convert back into plain text. Basically, we're performing the encryption in the reverse. So here's a simple substitution cipher. An example for this one is we have a key. An example key is, for this one, we have zebra. So our key is zebra. An example encryption key using the above key. So for example, we have zebra. So here, A, equivalent of A is P. You notice that the D equivalent of D is G here. Equivalent of E is I. Equivalent of F is U. Equivalent of E is I here. So why did we come up with this one? So there are, the key for the simple substitution cipher usually consists of 26 letters compared to Caesar's cipher single number. An example key is this one. So for an example encryption using the above key, it is easy to see how each character in the plain text is replaced with the corresponding letter in the cipher alphabet. So the encryption is just easy by going from the cipher alphabet back to the plain alphabet. When generating keys, it is popular to use a keyword. So example, our keyword is zebra. To generate it, it's much easier to remember a keyword compared to a random jumble of 26 characters. So we'll show you how we decrypt and how we encrypt and decrypt a simple ciphertext using a zebra as our key. So it would become our ciphered alphabet, zebra, Z, D, F, G, H, until Z. So we put zebra on the first row of the letters. This key is then used identically to the example above. So if your keyword has repeated characters, like for example, mammoth with repeated M, be careful not to include that repeated characters in the ciphertext. It means that hindi mo pwedeng gamitin ulit na merong katulad na letters. Yung substitution cipher. So here, notice that this is the ciphertext. We have, for example, we just use a simple substitution cipher. We just use this cipher alphabet. This is generated by us. You might ask, wow, paano nangyari? Bakit naging ganyan yung ano? This is actually a substitution cipher na ginawa natin. So, pwede magka-random yan, depende sa inyo. So, this is our encryption. Ang equivalent mo sa plain plain alphabet is, for example, ang equivalent ng A sa plain alphabet ay ng P ay A. Equivalent ng B sa plain alphabet sa ciphertext natin is H. So, example sa encryption na yun, pag kaya kinonvert natin dito, ito magiging itsura niya. Then, the next slide na pinakita ko naman, we uses a ciphertext that uses a keyword. So, a keyword that we use is zebra. Our cipher alphabet will be zebra. So, if we wanted to encrypt, defend the east wall of the castle, we will generate a what is D here. Our D is, so ano yung D dito sa katapat na plain text. So, ang gagawin nyo kasi, gagawa mo na kayo ng ganito, i-beat ito sa hanggang Z, dahil yung ciphertext, i-align para makita nyo. Okay? Nagets ba? Pag may question, let me know. So, zebra. So, sa zebra kasi, ang equivalent ng Z sa plain text alphabet is A. Ang equivalent ng E sa plain text alphabet is B. So on and so forth. Okay? I think that ends my slide. I hope you do understand. If you have other questions, please let me know on our GC so we can respond to your questions. Thank you.